Скажите, пожалуйста, а кто из вас знает, кто такой Брюс Экель? Встаньте, пожалуйста. Встаньте, встаньте, не стесняйтесь. Встаньте. Этот человек приехал в Беларусь, он супер волнуется, он очень хочет, чтобы вы с ним общались, правда. Он говорит об этом. Давайте поаплодируем ему, чтобы он выступил. Спасибо большое, мы начинаем.
So I'm sort of I'm somebody who has kind of focused on languages most of my life, and I'm trying to help move technology forward, or at least that's the way I think about myself in this context. And one of the things that I have been struggling with more recently is looking at what makes a language successful and what does successful even mean. You probably know me from this work, but I've also I started out in C++. I spent 8 years on the C++ Standards Committee. I also wrote these books. This one was my very first one, and that's my first C++ book that I published through a regular publisher. These things, I also wrote for magazines, which you probably don't have these anymore. Because everything's on the internet, blogs and things. My other project, which some of you came to last night, is this Reinventing Business, where I've been chronicling it on my blog, which is reinventingbusiness.com. So the question is, well, so I've spent all this time looking at languages. Do languages really matter, or do they still matter, or do they still matter as much, or probably more importantly, does arguing about, because we've spent a lot of time arguing about languages, does arguing about languages still matter? Answer's probably not nearly as much. If we look at the development of languages, at least in my lifetime, we started with, I began programming in assembly language and some of the more primitive languages. And when we moved from assembly to C, you could argue that that was a big jump, because we were going from having to manage everything ourselves to having a compiler take care of things like passing and returning arguments, which you had to do by hand if you wanted to have function calls. Assembly is still a very primitive way of doing things. And then moving from C to C++ allowed us to have maybe some higher level concepts, but still work with the C language. C++ then evolved Java. That was the reason, if you don't know the story behind it, Gosling and his cohorts were given the task of building a set-top box, which we don't have anymore, really, but that was a thing at the time. And instead of building a set-top box, they said, well, we hate C++, so we'll make a programming language instead of doing what the people asked us to do. So that's how we ended up with Java. And Java brought us virtual machines and garbage collection. Those are the two really big moves forward that Java produced. A lot of the other ideas were, we knew about virtual machines and garbage collection, but they weren't in the mainstream. And if you were to suggest that we could have, that we would ever be using these things in daily programming, people would scoff at it, because they would say, oh no, that's just not efficient enough. At one point, the SQL language was considered too inefficient to reasonably implement. So there's a lot of this kind of stuff that happens where people don't move forward because they go, well, that can't possibly be efficient enough. Then we moved into the statically typed versus dynamic language battles and problems with concurrency and parallelism, which is still an issue that we struggle with, especially now that most computers have multiple cores in them. How do we use those cores? The object-oriented versus functional struggles, which I'll talk a little bit about. So the Java Posse Roundup, how many people used to listen to the Java Posse or still do? So there's a few out there. So we had this conference in my town in Colorado called the Java Posse Roundup, where the Java Posse would come and and people would come. It was an open spaces conference, but eventually everybody kind of stopped talking about Java and moved on, and eventually the Java Posse itself disbanded, and so now it's called the Winter Tech Forum. Just to give you some information here, I sometimes try and paint, and so just for your entertainment, I've thrown in some of my paintings just to give your right brain something to look at. I remember Bjarne Strustrup saying that one of his goals for C++ was to make library use easier, and that has been an ongoing goal. That's where you get the biggest leverage, if you can just grab a library, stick it in, and start using it. Java, one of the things that it validated, as I said before, was virtual machines and garbage collection, and also being able to bring in lots of libraries, mainstreaming the idea of a big network. Before that, not network, a framework. Before that, the idea of a giant framework was it was almost too complicated to mess around with, and so all of these things started coming in. Ruby on Rails is probably the thing that more than anything else validated the idea of dynamic languages for big projects. People used to say, oh, well, a dynamic language is fine for scripting, for doing small tasks, but you can't do anything serious with it. And as time passed, and we saw more and more things being built with initially Ruby and other dynamic languages, people have had a harder and harder time making the argument that, it can't be done. And let's see. Okay, so my own experience was, I got involved with my friend James Ward, who at the time was working for Adobe, and he wanted to write a book. So we wrote this book on Flex, which was it was a closed source language, and it was for Adobe Flash. And probably familiar with what happened with Flash. It didn't keep up. And that was, I would argue, because it was closed source, it was based on whoever was running Adobe at the time, and they're going, this is doing good enough, so we don't need to put effort into this. And as a result, it fell behind, and they finally did open source it, but by then it was too late. And this is an example of what they call open source dumping, when Adobe says, we're going to open source this now, but it's, it was way too late, and so basically it's dead. It's, can't be, Apple certainly helped by saying we won't do it, but it was really ultimately Adobe's fault. If they had open sourced it sooner, it might have had a chance of being efficient enough that Apple wouldn't have pulled the plug on it. But anyway, so I don't want to mess with closed source languages anymore. So this is the Scala book that I spent a couple of years working on it. You can download it. So Scala's been an interesting experience and experiment. And ultimately, so I've held a conference called the Scala Summit several times, again, up in Crested Butte. And one of the things that I learned was that Scala is really an experiment to take object-oriented and functional and kind of mash it together and see what happens. And they've done all kinds of experimentation in it. And I think looked at as an experiment is probably the best way to treat it. Now, people are doing good work with Scala, but I think what they're doing is they're taking a subset of the language. And they're saying, don't use funny characters in your overloaded operators and things like that. They're setting up some rules. But Scala itself is kind of a Wild West, open, everything goes in Scala. And it's kind of a problem when you're trying to build production software unless you narrow it down. So one of the things that characterizes Scala is that it has a company behind it, so they created the company TypeSafe, and then they have Martin Odersky's group, and they're basically across the world from each other, and they're doing all sorts of very interesting things, but the question in my mind is how much do we want to use this in production code? It's really not clear to me at this point. If we do use it in production code, I think we want to use it in the narrow version. And I'm a little, I I guess, uncertain, because in the book what we tried to do was introduce all of the easy parts of Scala. And I am now kind of worried that that Diane and I made the language look too easy. You know, like if you just read our book, you'll go, oh, Scala's easy, we should use it. And there aren't any sharp edges and pitfalls and cliffs. And there are. And so, anyway, I think, so one of the problems that I think that I see here is that you have these two forces. You have Martin Odersky wanting to do experiments, and then you have TypeSafe that wants to be a successful Silicon Valley startup. And I think the two fight against each other, and I see that a lot when you have a company involved. Even though Scala started as an open source language, there was a company involved, and the motives of the company got involved in making decisions rather than just being, how can we serve the community best? It became, how can we serve the company best? So I don't really know what's going to be happening with that. Yeah, so one of the big problems was because of some internal turmoil in the company, there's been a steady stream of core technical people leaving. And so that's not a good sign. And then those of you who haven't seen Paul Phillips' presentation, you can go to YouTube. And he was one of the founders of TypeSafe, and he makes a pretty strong case that he's probably written more Scala code than anyone else in the world. And it's pretty believable that he's written enough to understand what's going on. So, and he makes some pretty strong arguments that you need to be careful about it. So as interesting as I've found Scala and as educational, I would say, well, right now we're going to have to be careful about it. Like I say, it can be very useful. We've got some arguments about motivations. The problem that ultimately that I've had is that you've got a motivation of commercial success and language experimentation, and neither of those, from my standpoint, is developer focused. Sometimes, coincidentally, we get benefits for the developer, but a lot of times we end up with some odd things that don't benefit the developer. And my interest is, how do we empower the developer? So, all right, so let's look at probably your favorite language, and I'm probably going to say some things that are going to make you unhappy. And the reason that I think, well, at least I'd like to think that thinking in Java is useful to people is because I point out the problems in the language. And so when you run into those problems, you're prepared for them, rather than you going, well, why did they do it this way? Am I just stupid? And having to go through the whole process that I had to figure out what's going on. And then I end up going, oh my gosh, they just made a bad decision here. Now I understand. So I tried to write all that stuff down so that when you encountered it, you were ready for it. And it wasn't such a big deal for you. So these are my opinions. Just because I'm unhappy with it, don't let it make you unhappy. Point out that, observe that ultimately I'm kind of a Python guy. So what the heck would I know? And then also, my real anger is because Java could have been so much better if they hadn't made sloppy design decisions. And so, and I know the history of this. If you go back, you can find interviews and, well, like in particular, Bill Joy counseled Gosling to put generics and I think even closures into the language in the beginning, which is when they would have had to have been put in to get done right. But Gosling kind of shrugged it off and said, well, we're in a hurry. So as a result, and so I run into this problem again, is that because Java's been created and funded by a company, Sun, and then Oracle, it's not developer-centric. It's driven by the desires of the company as well as the language designers working in the company. And that I think has given us things like, well, AWT, which I had somebody in one of my seminars who said, oh yeah, he was there when this was happening, and they designed it in, 10 days. which if you've ever looked at AWT, you go, yeah, that looks like a 10-day design. And applets, which one of the reasons that they rushed Java out and made so many kind of poor decisions at the time was that they go, well, because applets are going to be the way that the internet works, and so we got to get it out here. And obviously that didn't happen. We have generics with erasure, which is kind of an abomination. You know, we've gotten used to it, but again, it could have been done so much better. Vectors, if you've ever looked, fortunately you don't have to use vectors now at all, but if of course it's still in there because of backwards compatibility. But this was an example of just pure inexperience on the part of the language designers. Primitive types, excellent example. That was a short-term decision because they said, oh, well, otherwise it'll be inefficient. Not the case. Now we wouldn't have had to have primitive types, but it was just a quick and dirty decision. J2EE collectively has cost the world billions of dollars because it was an academic design and it was pushed on us by Sun as this is a great design. And turns out, no, it wasn't. It was a very bad design, but they had, you know, their marketing people were pushing these things on us. Genie, does anybody even remember Genie? You know, my friend Bill Venners was a big proponent, and they used to say, well, as an example, they would say, well, so this is a way to like hook your printers and other devices into a network. And I finally asked him, I said, so has anybody ever actually done that? And he goes, no. And there's, you know, no example or anything. So it's like when you don't have a good out-of-the-box experience. Anyway, checked exceptions, of course, enough said. Some of you may still feel like checked exceptions were a good idea. I've made many arguments to the contrary, and initially I was just booed off the stage for arguing against checked exceptions. But as time has passed, more and more people have kind of come around to going, yeah, that was a mistake, and no other language has adopted checked exceptions. So there's another argument that perhaps it was a poor choice. So, and these go on, and now we've got these non-closure lambda expressions. At least they didn't call them closures, because that would have been one of those confusing things. They admitted, okay, this is just a lambda expression. It just cleans up the syntax a little bit, but it's not a true closure because they would have had to they would have had to have done that at the very beginning of the language. So there's all this stuff that annoys me for sure. So I had to wade through all this stuff, and both the language designers telling us, no, we're smart people, we know what we're doing, and the spin from the marketers at the company, and you wade through this and you go, I must be stupid. I must not understand why this is so great. And eventually I would struggle through it and realize, no, this was a mistake, and they were just trying to pull the wool over our eyes. So, and then we've got the backwards compatibility thing, which prevents mistakes from being fixed. All right. So I could say that, I kind of said this already, I kind of think of what I've described in this book as quote, Java, the bad parts. But the reason is not necessarily, okay, yes, I am angry at the language designers in the company, yes. But the reason that I wrote this was that so you wouldn't have to struggle to figure that stuff out yourself. Everybody wouldn't have to go through the same learning process that I did. And I hope that it saves a lot of time and frustration. And so now, okay, am I really that down on Java? Okay, right. There's many arguments. It has brought a lot of benefit to the world. It's moved us forward a great deal, both with these issues and with others. It's the number one programming language. There's no metric that shows it as anything else. And that brings a lot of benefits. There's a lot of libraries out there that you can just drag in and use. So yes, Java has great benefits. The only reason that I'm annoyed is that it could have been so much better if people had thought about it a little bit rather than just rushing forward. So that frustrates me because it's the number one language now and it could have been better. And so as a result, everybody who's using it is slowed down by all of the problems. So it's Yeah, that's basically my argument. And I think eventually we will see, it'll be a while. It'll be, years before we see people start to migrate away from it. But eventually it'll happen, and Java will become a legacy language. This is the elves leaving Middle-earth. But it's not going to happen that soon. We'll still get lots of benefits from it. The virtual machine running on all platforms and the alternate languages on the virtual machine will benefit from the libraries. Lots and lots of benefits left. But I just, because Java has kind of boxed itself into a corner, it can only do so much. And I think maybe it's approaching the maximum of what it's been able to do, because every time a new feature is added, there are all these limitations. Well, an example is the lambda expression. It can't be a true closure because of backwards compatibility issues and everything. So we're starting to see it sort of hit the wall. And yes, we'll get lots of good use out of it. People will still start companies and use Java because there's lots of Java programmers out there, etc. All of that benefit will still accrue, but just be aware that probably in your lifetime, because things happen faster and faster, there may be a language that comes along and you look at it and go, well, we can have the benefits of Java and the much greater benefits of this new language. So anyway, despite all that, I have decided to finally update my writings on Java, collect them all together, bring them up to Java 8, and it'll be easier with Java 9. This will only be an ebook because there's too many pages otherwise. There's too much stuff in there. I'm kind of going back. I had to take things out of later editions of Thinking in Java because the book was getting too thick. So now I'm able to put those back in, bring them up to date, etc. I'm hoping within a few months you'll see this book and it'll be available everywhere. One of the things that I did was I converted it to, I've always, because I've been print oriented, I've used a tool that makes print easier, but since this is only an ebook, I've moved to Markdown. And Markdown is both terrific and horrible at the same time. There's like 11 different things, and we call them all Markdown. And so it depends on which one you're using, depends on what you can do with it, etc. Anyway, because of that, I'm able to do a lot more tooling to help the book development process. So that's very helpful. Anyway, there are some things about the language that I realized after my initial, I was very skeptical at first. Like, for example, as soon as I saw that lambdas weren't closures, I said, they're trying to push something else on us, and it'll probably be terrible. But it turns out that they are useful in reducing some of the visual noise that we see in Java code. The thing that I found is that there's you get used to it, and then there's a lot of places where you can't necessarily use them that you thought you might be able to use them, and that, of course, is frustrating. But there are things like this. When we combine it with some of the functional things that they've added, we can take, so we start with a list and we turn it into a stream, because these things are designed to deal with a stream of elements. We can filter it. We want to find everything that starts with a capital B. We want to turn this into uppercase and then collect it at the end to a list, and there becomes my list. Well, this is approaching some of the things that you can do with Scala. And again, this is probably not in as many cases as you could with a more general purpose functional language like Scala, but still, it's the kind of thing that might, and I think that's one of the reasons that they put this in, it might make people think twice before they go, we got to move to Scala because we need that kind of power. We're starting to see a little bit of that in Java. And my experience with starting to get used to functional programming was with Python. And Python started adding functional features, even though they said, we're not a functional language, we're just picking some of these things up because it makes programming nicer. And I think the same thing can happen here when you start seeing this is a much more concise and eventually, maybe at first it looks a little odd, but eventually it becomes a more readable way of looking at something that otherwise might be a complex piece of code to try and parse through. The new I/O stuff, that's always been when they said NIO and that's going to be new I/O, and you think, well, is it still going to be new 5 years from now? Well, they've changed the name now. N stands for non-blocking rather than new. And they've added some stuff here which is really programmer friendly. It makes your code cleaner, and that's usually my interest because I feel like code is read much more than it is written, and so you want to have readable code. And so they've added some features like paths and files, which make it easier to manipulate stuff in the operating system. Resource management. I suspect they might have picked up some of those ideas from Python because it's been doing it. And it makes it a lot easier to worry about your resource management. And this very cool thing called a watch service. Then there are things like type inference. So if we look at this over here, you'll notice that ordinarily, and again, an annoyance, because when this first came out, when we first had generics and we had to duplicate this on this side and that on that side, there was some sort of lame explanation. Oh, well, here's why you have to do this. And of course, I know that it's lazy compiler writers. And so finally, they fixed that. So at least you don't have to, if you have a complex expression here, you can just put in the empty diamonds and the compiler will figure it out, which it always could have done that. So that's a benefit. I like that. Switching on strings, well, I mean, that's not a huge, compared to, say, what Scala has with pattern matching, that's a minor step. And yet, still, cleans up your code a little bit in the case where you're switching on strings. I like this, being able to, again, make it more readable. What's interesting is how long it took before, and I think maybe something must have happened to where the language designer said, we really should start paying attention to readability. And so finally it happened. And these are things that should have happened at the beginning rather than more towards the end of the language. And then the multiple exception, being able to catch multiple exceptions at once. Again, more of a readability thing. All right, I like that. So there are definitely improvements, and that has softened my stance a little bit on Java. All right, what about the... when Oracle bought Sun, if Sun hadn't, I'm going to make this argument to say if Sun hadn't already had a commitment to open sourcing Java, that wouldn't have been in Oracle's interest and they wouldn't have done it. So that's a really good thing. Even though they've dragged their heels, I feel like they've dragged their heels because they want to maintain the lawsuit with Google. And so, none of that stuff benefits us or the programming world in general. You could make an argument whether Google was good or bad in that case, but if it was really an open source language at that time, it wouldn't have mattered. They wouldn't have been able to do anything about that. All right, so anyway, so again, because it was at one time a closed source language, we run into these problems. They're not good for us. They're just good, I guess, probably not even good for the companies that are fighting. But I think this handoff is going to happen. It is in the process of happening. I don't think Oracle could make it stop at any point. The reaction would be so huge. So it'll happen. But there are things like when Gosling left Oracle, that's not a good sign. And I think the attitude of Oracle impacts things. They're going to try and do whatever is beneficial to Oracle, and that's not necessarily going to serve the rest of the world. So I'm very careful about their motives, and I think you should be too. Don't trust them, basically. I know people who have worked within Oracle, so I have found out some of the things that go on there, and it's the usual stuff. Those of you who listened to my talk last night got a sense of what I think of power hierarchies, and they're a perfect example of the worst that can happen within a power hierarchy, so don't depend on. So here's an idea that I had, which I could totally see happening. That's somebody invents a new language starting from scratch, so they're not hobbled by the problems that that Java has accumulated, but they create a tool to convert existing, so it understands Java and it can rewrite it in your new code. So rather than us having to wait for everybody to rewrite libraries, this thing does it for you, and boom, you have the language and the ecosystem and mountains of tested code all at once. I wouldn't be surprised if this happens. Who knows? It could, but we'll see. But Ruby tried to do something like this with the Python libraries. Rather than rewrite them themselves, they made a connector to it. But I could certainly see something that would work this way. Who knows? Okay, so this will be my final work on Java. I mentioned the conversion to Markdown, and so I'll be able to more easily, when Java 9 comes out, I'll be able to update it, etc. And so the title of this talk is is more than a language, and if I've been disappointed with the languages that I'm talking about, what does it take to make a language that I like? These three things: design, culture, and community. I think the language needs to be designed thoughtfully and not in a rush. It needs to, and when I was on the C++ standards committee, that's what I saw. You can argue about the complexity of C++, and I will agree with you on that. But I know the reason for the complexity, which was their primary goal was backwards compatibility with C, so that a C programmer could move their code into C++ and have it work. The cost of that compatibility was things like, if you wanted to overload an operator, you ran into some, well, you had to pay attention to a lot of details. I used to be able to explain operator overloading in C++ to people, and I've forgotten all of the intricate details because they were just details that you had to pay attention to. And those very details are the ones that made, when they were designing Java, most of it has to do with the lack of a garbage collector. So they were designing Java and they said, well, operator overloading is too complicated. Well, that was the complication. They didn't realize that, well, we have a garbage collector, so that complication goes away. They didn't understand the problem, which, again, is why I have not a huge amount of faith in the original language designers, because they made basic flaws of misunderstanding. Culture and community are closely tied together, but I think it's useful to look at them separately. So to me, the important thing about design is that it be programmer-centric. People who design with efficiency in mind, or other issues, or, how can we make this language generate a lot of money for our company, any of those things, that doesn't ultimately help the programmer. So clarity, simplicity, power, all of those things that are designed to make your life as a programmer more productive. To me, that's ultimately what pays off. Culture includes things like either an explicit or implicit code of conduct based on, well, this is my value, based on being nice. And I bring that up because when I was writing the Scala book, and those of you who have dabbled in Scala know one of the pitfalls is you have a question and you wander around and you find a likely looking news group and you walk in and ask the question and you exit hastily with your head on fire because you can just be flamed. It's some of the news groups are very nice, but some of them are downright hateful. And you're going, wait, this is a programming language. Why are you guys so like this? And I'm still not sure. I have been around long enough to know, we will mark this door do not enter, and I went and found a news group that was nice, and they answered my question. But just encountering that kind of thing is not something, especially if somebody's trying to learn the language, it's not something that you ever want someone new to ever encounter. And this needs to be supported by the community, this kind of culture of niceness. And Java's okay, although in the past it's had its kind of turbulent moments. I've mostly ignored all that. The community, I think, needs to be friendly, helpful, and inclusive and diverse. And I think the last is a really important thing to point out. And I'll say, I've already said I'm a Python guy. I've fought it for a long time, but ultimately that's what I am. So one of the things that I noticed about the Python conference is that, like the last conference I went to, they had probably 25% women at the conference. It used to be you'd go to a conference, you might have 1 or 2% of women, and they'd be hiding, saying, "Yeah, don't pay any attention to me. I'm not really here. I don't want to be bothered," etc. Now, and the women at the Python conference are actively involved and engaged, and there are also lots of other minorities. Well, not women aren't minorities, but there are minorities represented, and everybody feels comfortable. And I really appreciate that. I think that's important. And I know that in a lot of communities, it can seem like they're inclusive, but if you look around and there aren't others, folks who are not, you can look around and see whether it's inclusive or not. And I think that is critically important, because diversity makes your company better. And I don't mean better just because you're doing good. It's not that. You will make more money because you bring other viewpoints to the table when you do things. It broadens everything. And so you will be more profitable. So if for no other reason, that's why you do it. And you're not checking boxes. You are including everybody. Really important. So just a little aside, I've been struggling with the idea of culture. I have friends who work at Netflix, and I visited there, and they're big on culture. And the way they do culture is they see if you're a cultural fit, and if you're not, they pluck you out. They give you a nice severance and send you on your way. But I wonder, the thing I'm struggling with is, where is the line at which you can say somebody can learn new things versus they're just irredeemably not a cultural fit? I'm just going to throw that question out there, because I wonder where, I feel like Netflix is too draconian in their approach. So anyway, that's an important issue for me. So to compare languages, and actually for this conference is what got me started looking at this. To compare these languages, I started creating a table. So the last thing that I created was a language evaluation checklist. And my friend James, who used to work for TypeSafe, filled out the one for Scala, and then I did one for Python. And basically, I guess I've talked enough about the Scala one to kind of cover that. The Python one, and as I said, my goal is to go live in the Python community and pull the whole in after me, because they started from the beginning with a developer-centric approach. That's why I think the community is so good, because there was briefly a company that tried to manipulate it, but they were able to get out from under that and just make it developer-centric. One of the things that happens is at the conferences, so when you speak at the conference, you still have to pay the entrance fee, which sounds a little weird, because most of the time you go speak at a conference and they'll pay for things and maybe even give you a stipend. But here, you show up at the Python conference, you're still paying to enter the conference. But what they do with that money, for example, is, they help support the development of Python. But I think there were 100 students who they gave scholarships to come to the conference, and that meant all of the expenses, travel and lodging and everything. And I feel very good about, even if I'm speaking at the conference, paying for to help things like that, bring new students into it, and the inclusiveness of the community and everything. It's worth seeing. So that's what I would like to see more in other languages. And then the last language that I wanted to show as an example is the Elm language. So how many people have heard of this language? It's called Elm, and it is designed to basically take us up a couple of levels above JavaScript, including, because a lot of what you find with layers over JavaScript is, well, it's a language which mitigates some of the issues of JavaScript, but you still have to deal with frameworks and, choose from the 100 or more constantly evolving and being created frameworks. So Elm is looking at the problem in terms of creating a pure functional language with the idea that the framework is basically incorporated into the language, which I think is an important step. But there's a presentation that you can find on the internet where the creator, Evan, I think he's Czech or something. Anyway, his last name starts with a CZ. Anyway, he describes what he's trying to do, and he says some very interesting things. One of the most interesting things he says in the presentation is that he believes that when you introduce a feature, a language feature is part of that feature. So if you introduce, take Scala as an example, if you introduce some very difficult and obscure feature right at the beginning, then the community will form around those ideas. And I think that's pretty much what has happened. By and large, the Scala community is very comfortable and even interested in complexity. And whereas he says if a feature is more complex, you want to introduce it later so the community forms around the simpler, more straightforward ideas, and then once they're comfortable with those, then you introduce more complex features for more power, but the idea of the core is still aligned with these simple features. So ultimately, that's what I'm looking for. This is why I'm talking about a language as more than just the syntax of the language or even the tools of the language. Another example is Go. I have a lot of respect for Go because, for example, they have the Go format tool so that the whole formatting issue is taken off the table. It's not even something anybody can argue about. And whenever you look at Go code, it all looks the same, so you can focus on the code and not having to parse through how did this person format differently than that. We've wasted way too much time on that. They've done a number of other things that I think are quite brilliant. I don't use it myself because I think I've gotten too used to having classes as first-class entities. And even though you can create structures and attach functions to them in Go, which is okay, I don't know, something holds me back from it. But there are other things like having communicating sequential processes as first-class entities so that you could teach someone Go, and at the end of the first week, they could safely be doing parallel processing. You cannot do that yet maybe we'll never be able to do that in Java. It requires a lot of background before you can safely, even if there's some argument whether you can even safely ever write parallel code in Java and in numerous other languages that support it. And I know I'll have probably some people come up and say, well, I know you can't write parallel programs, but I can. That scares the heck out of me when somebody does that. Anybody know what the Dunning-Kruger effect is? Okay, it means, good, we have at least one person. It means that the less you know about something, the more confident you are in your abilities in that thing. So if I'm in a car with somebody and they say, I'm a good driver, scares me. because, I want somebody who goes, well, so far I've never had a crash, but, it could happen. That gives me more confidence because they know, they understand a little bit more about the physics of the car. So anyway, that is essentially, unfortunately, technical difficulties, so probably pushed things a little too hard. But that's essentially what I wanted to say. Do I have time for questions? I do? I have time for 2 questions. Well, wait a minute. Shouldn't I have time? Because I have 3 beer tickets. Shouldn't I have time for 3 questions? Okay, I can have 3 questions. Short. Okay, they have to be short questions, so nothing that will stump me or... yes, here.
Yes.
Okay. Well, you can come up and get your beer ticket afterwards from me.
Okay. So, quick question. When you're saying that there are the good things, the good language, or like the whole ecosystem needs to be started from scratch, and there probably, right? And
easier. Let's say it's a lot easier to do it that way. Okay.
What kind of environment you think could start this sort of language or environment, given that if that's a company, it will care about revenue streams.
Right.
If it's a single or 2 persons, they just don't have resources.
Yeah, well, I think in the past they haven't had resources. Now, and Python's probably a good example, although that was started within a company organization. This guy, Evans, anyway, the guy who's starting Elm seems to be doing it pretty independently. He's working for the Czech company that makes the visual thing. So, but it seems like I think it more has to be the agreement that yes, I'm creating this language and you're helping support it. But the fact that we have open source languages now, and that he can say, well, I'm creating this as an open source language. If you don't like that, tell me now, because once it's open source, you can't shut the door on it. And then the company says, oh, we like it. And if they change their mind, he'll go someplace else. I mean, Guido he's moved a number of times. And so he can do a job and he'll go someplace that says, well, yeah, you can work on Python half-time or whatever, and we're good with that. So I think it's more the examples that we have set that people can follow now, rather than the old idea that, well, the company owns every thought that you have in the middle of the night, which is really, you used to have to sign a contract, and maybe you still do, I don't know. I haven't had a job in such a long time. Yeah. So, another question. Any more questions? Oh, yes, here.
I'm just wondering, what do you think, would Java adopt new features like from functional world before, I mean, would it get adopted in incorporation and things like that?
Let's see.
If it like become like Scala or Python.
Well, I mean, for one thing, I think it can only go so far, and in fact, we might have seen as far as it goes, or close to that. As far as the companies, I don't know. I feel like there's a lot of companies that have gotten to the point where, it used to be, it's like, oh, Java, that's new and weird, we don't touch that. And now it's become, oh, well, yeah, Java is the standard, and so we're using that, and so anything that's officially in Java, they would find acceptable. That's kind of, I think, the way the mentality has gone. But I think the real question is, how many more functional features could be crammed into the language given the constraints of backwards compatibility? And that, I think, is where we're starting to see the limitations. Okay, so I can take one more question. Why do we have the guy who's broken his toe carrying the microphone around? This is a bad... Okay, who's asking? Okay, you're asking the question.
Me. Okay, why we still stick to this backward compatibility? Can we just implement those new features in new, say, Java 10 and lose this backward compatibility? But we'll have no erasures, we will have proper closures, and etc.
I think that would be a different language. I mean, I agree with you, but I think that maxim was hard. That was cast in concrete when they started Java, even though, I mean, the thing is, there are companies that are still using like Java 1.1 because they don't want to shake anything up. So the value of backwards compatibility is very questionable because it seems like the ones that really want it aren't moving forward to new versions of the language anyway, so why not? So one of the things that Python did, which has been a lot harder than they thought it would be, is when they went from Python 2 to Python 3, is they did some breaking changes because there was stuff that clearly needed to be fixed. And that's one of the things that I really like, is that they actually made that hard decision. But I don't know of another language that has made a decision like that, where they said, all right, we're gonna do something that's actually gonna break old code, but it's for a good reason, and makes the language easier, more powerful, etc. And so we're going to do it. Everybody batten down the hatches, be ready for it. Maybe Java will get to that point, but I just feel like that agreement has been cast in stone for so long that, because the problem is that it affects other languages on the JVM as well, because of the erasure issue. For example, you can implement generics, like the generics in Scala still have to suffer from some of the aspects of erasure. So it's really kind of a damning problem. And but I don't have as much sympathy for those very real issues. My interest is in, let's create a better language. And then somebody will explain to me, well, you know, if we did this, it would cost us millions in time and everything, because it would, the kinds of things that would get broken. So I have to go, okay, you understand this issue better than I do. I'm really interested in how do we make a better language for better programmer productivity, which I think will ultimately win out. So that's why I think, because of these issues, eventually, 10 years or so, Java will start fading, maybe sooner. It'll start fading and some other language will move forward. It's just the natural way of selection, natural selection will happen. So, yeah, I think it's just because that agreement was cast in stone, and one of the things they don't feel like they can change.
Bruce, thank you.
Thank you. Thanks for bringing me here. Okay.